Ramzan Mubarak, and thank you for joining in. Uh, what we are going to do is we are going to go over the basic concept and then doing the past paper questions. But the topic that we have today, it is not tested directly so much. There are MCQs which are on this topic, Introduction to Organic, where they ask you about isomers, where they ask you to identify different kinds of reactions or to create isomers and all that. But this is not directly tested yet. It is vital that you understand this because इसके बगैर you will not be able to move on. ठीक है? I'm glad you can hear me now. So yeah, let's get started. So what I was saying before was that you have four main elements that are going to be used here, and they are H, O, and C. 1, 2, 3, 4, which is the number of bonds that they make. Yet sometimes nitrogen can make 4 bonds and carbon can make 5 bonds. So if you see carbon making 5 bonds and nitrogen making 4 bonds, don't worry. Now, carbon cannot make permanent 5 bonds. Carbon can make temporary bonds. वो आपको लगता है कि वो 5 bonds हैं, but they're not technically 5 bonds. It's just that when carbon is going through a transition in an intermediate state, you will see 5 bonds. Those are shown by dotted lines. So dotted lines can mean two different things in organic compounds or in this context. The first one is that if you see something like this. Now here, let's suppose I have this, then what it means is that carbon has 3 other bonds with something else, but these two are temporary bonds. One of them is going to break and one of them is going to make to be permanent. So this is an intermediate state where carbon can show 5 bonds, but it simply means that one of them is breaking and one of them is creating. The other case where you will see a dotted line, that will be if you see something like this. In this case, what this means is that over here, carbon has permanent bond with this as this. So ये दोनों permanent हैं. ये इनमें से temporary कोई नहीं है. This is not an intermediate step. It is simply that this one is in the front of carbon and this one is in the back of carbon. So this, you should be able to visualize this. Okay, this is in the front and this is at the back. It's a 3-dimensional thing. Or in other words, this is into the plane of paper and this is outside or protruding out of the paper. Assalamu alaikum and happy Ramzan to you guys. Alright, so these are the cases where you will see dotted lines and wedges. Then we have some terms that you should know before we move on. For example, there is X. X will simply mean group 7. Okay, or group 17. So that means we are talking about chlorine, bromine, fluorine, all of those. So we will use X. We will not write chlorine or bromine unless उसके specific कोई बात हो रही है. Secondly, HCs will simply mean hydrocarbons. Okay, so if it is HCs, that means it's hydrocarbons. So compounds made of hydrogen and carbon only. Okay, sometimes you will get substituted hydrocarbons. Substituted hydrocarbons का मतलब क्या होता है कि for example, if you have this is assumed that there is hydrogen on all 4 bonds here. And if you see this, then this one is a substituted hydrocarbon. It means that one of those hydrogens or 2 or whatever, they have been substituted, they have been replaced by something else. Now, there is another term that you should know about, which is saturation. Saturation simply means that a compound has all the single bonds that it can make. It's important to remember this, that these are single bonds. No more single bonds can be made. I'll give you an example. If you have carbon making double bond with this carbon and making this compound, then this is not saturated. This one is unsaturated. Why? Because it is possible that this carbon makes one more single bond and this carbon makes one more single bond. And there are ways to do that and they will eventually do that. Okay, so this one is saturated. So saturation is another term you should know about. Okay, so now new bonds can not be made unless it's sometimes in some compounds you can make dative bonds, but यहाँ पे हम उसकी बात नहीं कर रहे हैं. Okay, then there's 2 more terms that you should know about. There is functional group and there is homologous series. functional group is basically group of atoms or just one atom that give it that gives some more reactions to a compound. It we call them characteristic reactions. कि उसकी वजह से it has some extra abilities, extra powers जो उसके अंदर आ जाती हैं. Those are functional groups. So for example, OH can be a functional group because this makes things behave like alcohol. So any compound with OH will behave like alcohol. Before it cannot. So OH gives it alcoholic powers. Similarly, you can have chlorine, bromine, iodine, they can be alcoholic powers. Rafe, we will be going through as much of introduction and isomers and nomenclature as we can. But I'm hoping कि हम तीनों ही कर लेंगे. Isomers, nomenclature and introduction to organic. Homologous series is basically every functional group has its own homologous series. So if you have OH, it makes that's a functional group, but it makes homologous series of alcohols. If you have COOH, then that's a functional group, but it makes homologous series. So homologous series are at compounds with similar properties, trends in chemical properties. So this is what you need to know. They have similar chemical properties. They have trends in physical properties. Okay. They differ by CH2 between consecutive elements. So for example, methane and ethane will differ by CH2. This is again from O levels and IGCSE that you already know. These are the three main things you need to know about it. There are other important parts of homologous series as well, but these are the main three things. Examiner B usually they just ask you to write 2 points or 3 points, so these are good enough. You can write more as well, but this is good enough. Alright, now let's look at some functional groups and what do they do. So the first homologous series we have is alkane. Do they have a functional group? No, they don't have a functional group. They're simply hydrocarbons, and those have single bonds only. So they have this property that they are saturated hydrocarbons. Okay? So saturated hydrocarbons. Then we have alkenes. Alkenes have to have C with double bond. This is again something you already know. How do we name them? We simply say that this one is alkane. So if it is 4 carbons butane, 3 carbons propane, and this one will be whatever that is, then X that ene. X means which carbon has the bond. So we will do some examples of that and you will see that, for example, this one, if I have that and there's a double bond here, then this thing is very different from if I had like a copy of this thing but a double bond on the first carbon. Okay, so for example, if I have a double bond on the first carbon, ye yahan ki bajaye idhar hai, so these are two completely different compounds. So this one will be, both of them have 3, so bute, ene, and the X part tells me that I'm talking about the number of carbon. Now, which number do you pick? Now, remember this rule. Always go for smaller numbers. If you have a choice, always go for smaller numbers. Okay? So, over here, 1, 2, 3, 4. So, you can say like, okay, 2 and 3 both have the double bond. But go for smaller numbers. So, you'll write 2. So, bute-2-ene. Now, does it matter whether you go from right or left? No. 1, 2, 3, 4 or 1, 2, 3, 4. Your choice. Doesn't matter. But always go for smaller numbers. Let's do this one. Let's number the carbons. So this is carbon 1, carbon 2, carbon 3, carbon 4. Which one has a double bond? Carbon 1 and carbon 2. What will we write? Will we write bute-2-ene or bute-1-ene? We'll write bute-1-ene. Why? Because always go for smaller numbers. So that's how you name them. Now remember this thing. Every time you see organic compounds, unke naam mein, in the name, you have the main chain, you have the, which is called the stem, you have the function groups, and you can have more than one functional group. So if there was one more function group, it will come here. And we will do some more examples of that as well. Alright. Then there is alcohol, which you already know. This is alcohol is OH. So the functional group is OH. The homologous series is alcohol. And then this one can be called hydroxy or alcohol. So if you're talking about it just as a functional group, then you call it hydroxy. But if you're talking about homologous series, it's alcohol. So function groups make homologous series. Okay. So for example, if I had this, so this is simple. This is alcohol, but with 2 carbons. So ethanol. Why did I not number it? Because it doesn't matter. If this was not here, it was here, it will still be the same compound. Now, let's say I had more like 3 carbons. Now what is the name? So let's number it. 1, 2, 3. Will we do that? Yeah, will we do this? 1, 2, 3. Rule kya hai? Always go for smaller numbers. So we will go with 1. We will start counting from the functional group. So it will be prop 1 ol. Okay. Now let's say I have this here. So this one again, I start counting from left or right, doesn't matter as long as you go for smaller numbers. So 1, 2, 3. So this one is 2. So prop 2 ol. Now it is ol because it has alcohol group. Now let me write another one. What if I had this? So now I have 2 function groups. I have alcohol and I have double bond. So I'll call it prop because it has 3 carbons. Usually we don't need to write for prop. In में हम number नहीं लिखते, but just for the sake of simplicity I'm gonna do it. Okay. Sir, thank you so much sir. इज्जत दे रहे हैं, बहुत शुक्रिया sir. So 1 in, usually don't write 1 in. Prop में हम नहीं लिखते, but I'm just for sake of simplicity I'm doing it. 2 ol. So notice that we have 2 functional groups. We have the double bonds here, although technically they're not considered function group, but still, so double bonds, and then OH is on this. So how did I write them? Prop 1 in 2 ol. So, and that is fine. Okay, let's try another one and you will do it. Okay, go on. Name this compound. I'll give you a minute. Okay, so this should be, first it has 4 carbons, so bute. Then it has the double bond and it also has this. So how do I start counting? I will start counting so that I have smaller numbers. So 1, 2, 3, 4 or 1, 2, 3, 4. So clearly this is giving me smaller numbers, so I'll go with that. So bute 2 in because alkene 1 ol. There you go. So we have written the name of this compound. Okay, so that's how you name these things. Now, what if you have more than one of these functional groups? So for example, if I had the same thing, but this time, this thing, it had another alcohol over here. So now you will use 2 things. I call it LCN. Location, counting, naming. Okay, locate, count, name. That's what you have to do, LCN. So because you have 2 functional groups, so first locate both of them. So this one is on the carbon number 1, this one is on carbon number 2. Count them. How many do you have? You have 2. So it will be 1, 2, die. Die because there is 2 of them. Okay, so 1, 2, die. So location is 1, 2 and counting is die and name ol. So that's how we will write it. So it will still be bute 2 in, but then it will be 1, 2, die ol. Okay, so that's how we will do it. I will come to I will tell you about priority in a bit. Okay. So that is how you name when you have multiple functional groups. And it doesn't matter whether you have 1 or 2 or 5, as long as you have them and this is the way you write them, always go for smaller numbers and write them LCN. So this is the second rule you need to know for naming them. Location, counting, naming. Locate, count, name. Okay, so LCN. So this is the second rule you need to remember. First rule was always go for smaller numbers. Second rule is LCN. Alright, then we have ketones. These are the next ones. Ketones, aldehydes, carboxylic acids, and acyl chlorides. They all have very similar things. So acyl halides or acyl chlorides, that they all have carbon with double bond, oxygen. That is what they all have. Okay? And because of that, they are very similar in some reactions that they do. They all have this. Very similar to alkanes, alkenes, alkynes. They all have hydrogen and carbon only. So these are all with carbon with double bond oxygen. Mohsin, yes, that is the goal. Baki Allah himmat de. Let's see. Alright, so now how are they different from each other? With ketone, you have carbon on both sides. So this carbon is in the middle, it's sandwiched between both the other two. In this one, you have carbon on one side, but hydrogen on the other side. Now, does that mean you can't have carbon on the other side? मतलब यहाँ पे कार्बन नहीं हो सकता है, but then it will be a ketone. अच्छा, यहाँ पे hydrogen हो सकता है. There is one case where you can have a hydrogen here instead of carbon, and that will be methanol, and that's fine. Okay, so there is one case where you can have hydrogen on one side, on both sides, but in other cases you have to have hydrogen on one side. Then you have carboxylic acid. Carboxylic acid will have OH instead of directly being connected to H, but this side will have carbon or OH or something else. And acyl chlorides have Cl here. We mainly study them in A2, not in AS, but you still need to know about them. Okay, so these are all the compounds with C double bonded O. Okay, so that is something you need to know about. I'm sure you know the naming of these. So this is on, this is al, this is NOIC at the end of the name, and this is acyl chlorides. So benzoyl or all that we see. But जब इनके नाम आएंगे तब हम उसकी बात करेंगे. Yes, it will be available, Mohsin. Alright. Now, functional group, as you can see, they have similar chemical properties in all the all the members of the homologous series. They have trends in physical properties like boiling point and all of that. Why is that? So for figuring out one homologous series from the other, you look at the kind of bond that they have. Look at the intermolecular forces that they will have to figure out whether one will have higher boiling point or one will have lower boiling point. Similarly, you need to figure out the polarity or non-polarity of that homologous series. So that is something you should know about. So I'll give you a question. Why does alcohol dissolve in water, why does ethanol dissolve in water but ethane does not? It has to do with intermolecular forces. Ethanol has hydrogen bonding that it can make with water. Ethane cannot. Ethane has simple van der Waals forces, but ethanol has hydrogen bond. So because of the difference in bonding, they can make, one is soluble, one is not. Why is octanol insoluble in water but ethanol soluble in water? Octanol and ethanol, what is the difference? One of them has 2 carbons with OH, and one of them has 8 carbons with OH. So the difference is that this part has hydrogen bond that it can make, and this part has simple van der Waals forces. This long part has simple van der Waals forces, London forces, and this small part has hydrogen bonding. So obviously this is much smaller than the tail that you have here. So that is the dominant force. Here, this is a pretty dominant force. It can still make hydrogen bond and dissolve in water, but this one is too small and this one is too long to make any reasonable effect. So this is insoluble, this is soluble. So solubility, boiling point, all of that you have to figure out from the intermolecular forces. Another question, why does ethanol have higher boiling point than ethane? Simple, ethanol has hydrogen bonding or permanent dipoles, and ethane has simple induced dipoles, ID forces. So because of that, because they are weaker, it will have lower boiling point. Ethanol has hydrogen bond, higher boiling point. So again, it comes from the intermolecular forces. So that is something you should know about. Similarly, they also ask you within halogen alkanes. So for example, if you have carbon with let's say chlorine, carbon with bromine, which one will have higher boiling point? What do you think? Take a guess. Which one will have higher boiling point? So for that, you have to look at which dipole is stronger and what kind of forces will they make. Okay, so the boiling point of bromo will be higher than the chloromethane. So that is why. So in this case, you can see that iodide will give us a higher boiling point than, that is the way basically. And again, it has to deal with the strength of forces and whether one of them makes stronger intermolecular force with the other or not, even though they all have similar dipoles. In fact, इसमें सबसे ज़्यादा difference in electronegativity है. This is lower difference in electronegativity. This is even lower difference in electronegativity. So the size of molecule, as you said, size of this side is much bigger, and that is why electron density is less. वो सारे factors इसमें आ जाते हैं. You can read about it in the book if you feel like. So because the dominant part, that is what matters. Where does the dominant force come from? So the dominant force is not कि इनकी polarity है ज़्यादा और इसकी polarity कम है. That is not the dominant force. So there is permanent dipole. Boiling point depends on whether they make permanent dipoles of greater strength or not. Okay, and this has more electrons. And more electrons means कि जब dipole बनेगा, then that dipole will be like, it will have stronger forces. And that is why this has more electrons, so stronger dipole. This one has fewer electrons, so less strong dipole, which is why the forces will be more stronger here, higher boiling point. Okay. You have exam in 2 hours. How to pass? 2 hours में तो अब आप पास आउट ही हो सकते हैं, पास तो नहीं हो सकते अगर बिल्कुल तैयारी नहीं है, विच इज़ फाइन, कोई बात नहीं, ठीक है, इट्स अ मॉक. Alright, so this is basically the basic ideas that they have about molecules or bonding and all of that. We'll come back to naming, we'll come back to this. Let's move on. Next we have different formulas. I'll quickly name the formulas: empirical, molecular, and the rest of them. What do they tell us? So empirical formula does not tell us much. पहली बात तो ये कि empirical formula हमें बहुत ज़्यादा नहीं बताता. It simply tells us कि उसमें है क्या और उसकी ratio क्या है. That's all. ठीक है. So, but with empirical formula, if you have, so empirical formula hoga, and if you have the MR, then that gives us the molecular formula, which tells us a little more about that thing, the exact numbers and everything. Molecular formula with bonding information will tell us about the structural formula, and then structural formula as well as the displayed formula. And this thing with orientation information, this can also give us the skeletal formula, by the way. And then with orientation information, you can have a 3D formula, and that is the extent of all the different formulas that we see. You should be able to read all the formulas. I have uploaded a video in case you want a refresher on these. Okay, so that is basically the different kinds of formulas we have and how we represent them. You should be able to write the 3D or stereochemical formula that you have. ये पढ़ना आना चाहिए, इसमें differentiate करना आना चाहिए दोनों चीज़ों का. Okay? Alright. ठीक हो गया. So there's that. Now let's practice some nomenclature. Is there a way to like put a timestamp here? Yeah. Okay, so now we are going to practice different questions for nomenclature. Now, how does the nomenclature work? You have different prefixes that they come before the name. So they can be 1, 2, 3, 4, however many. Then you have the main chain, okay, which is called the stem. So it's the longest parent chain in the compound that matters. And this then comes with the stem suffix. So stem and then stem suffix. What does that mean? If you have alkene and the double bond is there in the longest chain, so it will be, the suffix will be -ene here. After that, you have the functional group suffix. Okay, and it's always the main functional group. Other functional groups come here. So if you have two function groups, three function group, they will go over there in the front, but the main one, which is the highest priority one, they will come at the end. So how does the priority work? So this is the third thing in naming that you have to know. The priority is like this. सबसे पहले you have carboxylic. That is the first one. Then aldehyde. Then ketone. Then alcohol. Then amine. It can be 1, 2, whatever. And then X. Okay? So that is how we prioritize them. So if you have any two of these, or three or four, or even if you have all of them, one will go here based on the order of like the priority. Everything else will go here. Okay? Electron number affects both of them. Permanent dipole is affected because of electron number of electron as well as the electronegativity, but it affects both of them. Okay, all right. So coming back to this, so the priority, one of this in order of their priority will go here, but everything else will go here. So this is the third thing you need to know about. So far हमने क्या क्या पढ़ा है? We have studied that first you should pick the smaller numbers. Okay, so that is the first one. So उसके बाद हमने ये सारी इनके priority पे आना है. Let's do some examples. Okay, here's a compound. So I have a list here. So let's try to name it. Now, don't just sit there idly. Try to name it as I write it down. Okay. This one is pretty straightforward, propanoic acid, right? But what if I add OH here? Although I've not shown the bond between O and H, but अब इसमें क्या होगा? The priority goes to carboxylic acid. So it is still propanoic acid. Now, how does that come out? First of all, what's the parent? Parent is the longest chain, so 3. So prop. Parent chain has just single bond, so ane. If it had a double bond, it will be ene. And then NOIC for the propanoic acid. And then the second one will be 2-hydroxy. Where am I counting from? 1, 2, 3. Remember that I'm not counting from here. That's wrong. Why? Because I have to go for smaller numbers. So 1, 2, 3, and the second one has hydroxy. Now, why did hydroxy go in the prefix and not here? Because the main functional group is carboxylic acid. Okay? So that is how we name them. Usually, if you have just the first propanoic acid, we will not write propane 1. We usually don't write it. We don't really need to. Okay, let's try one more. So this time I have structural formula. Okay, so first identify the function group that you have. Obviously halogen, alkane, aldehyde. So obviously the aldehyde is the main function group. 3 carbons, so prop, ane. So main stem is prop, the stem prefix is ane, and then aldehyde, propanol. Okay, so there you go. Then you have chlorine, so that goes over here. But what is the number of carbon? So that is something students sometimes struggle with. So remember, the number of carbon now will set from the main function group. So this is first carbon, second carbon, third carbon. Okay, remember this. So you have 3 chloro. That's how we name it. Let's try one more. Okay, so this time we have alcohol. This one is pretty straightforward. This one, sorry, I should change that. This is too easy. Let's do this. Okay. Now you have aldehyde as well as alcohol. So which one comes first? The priority goes to aldehyde, not alcohol. So this one will be first carbon, second carbon, third carbon, and then the name would be propane. So parent is prop, parent suffix is ane, and then propanol, and then you have second carbon with 2-hydroxy. Okay, so just like this one was 3 chloro, this one is 2-hydroxy. But even though they both had different functional groups, the one that has higher priority comes first. Okay, let's take one step further. So this one I'm gonna draw this out a little bit. Okay, let's try to name this one. Again, सबसे पहले identify the main stem. How do you identify the main stem? Pick a pencil, try to connect as many number of carbons as you can without picking it up and without going back. Without picking the pencil, without going back. So 1, 2, 3, 4. That's the longest I can make. Because if I try to go back, that's not possible. So the 4 carbons will make. So this is my main stem. This is my main stem. Okay. Now, so this is bute. Main stem has a alkene in there. So butene. So main stem suffix is gonna be 2-ene or parent stem suffix. Okay. Now you have this alcohol. So butene 1-ol. Okay. So there is alcohol here on the first carbon. So this is 1, this is 2, this is 3, this is 4. Now this one is it's an alkyl. So this is going to be 3-methyl butene 1-ol. There you go. So we have named it. Alright. So that's how you find out the names. Okay. Let's try to identify the long chain. एक second लगाते हैं ज़रा. So I have this one. Can you tell me the long chain here? Okay, which one is the long chain? Is it this? It has 5 carbons. I don't think so. Is it this? 5 carbons? No. 6 carbons here. So no. Maybe. And 4 and 6 carbons here. So which one? Is it this one or is it this one? Turns out it could be either one. You can name this as the main one and then these go in the branch. This one and this one. And you can make this one the main one and this one and that one go in the branch. Okay. So it will be up to you which one you identify, but name will not change. The other two will become branches. Question is, sometimes we will have to choose the chain with more function group regardless of how long it is. Sometimes it happens, yes, because we don't want to, if you have more function groups on one chain, we try to like stick with that and put the other ones in the branch. Naming आसान हो जाती है. So yeah, you're right in that. Okay. So that is how we identify those. So, okay. So we have seen the main rules. Now, cyclo, I'll tell you what the cyclo compound. So for example, this one, there is no double bond, but these are making 6 carbons in a chain. So this is a cyclohexane. Okay. So the cyclo compound, so for example, if this one is chlorine, so it will be 1-chloro cyclohexane. Why? Because now I'm starting counting from here. I could start counting from anywhere, but this is where I'm gonna go. Secondly, if you can pick, if you have multiples, for example, if I have this bromine, so now this will not be 1, 2, 3, 4. It will be the ones where I can pick smaller numbers. So 1, 2, 3. So it will be 3 bromo, 1 chloro cyclohexane. Or it could be 1 bromo, 3 chloro cyclohexane. Up to you. Usually we try to go with smaller numbers in alphabetical order in such scenarios. So हम इसको 1 bromo 3 chloro बोल देंगे. But in your exam, if you don't follow the alphabetical order, you will not lose marks. Okay, so that is also something you should know about. Okay, we have looked at the other rules, so now let's look at some examples. One case of carboxylic acid where you can have multiple carboxylic groups. So in that case, you get dioic acid. Okay, so I'll give you an example. Let's say I have 4 carbons, but they have carboxylic on the end of both of them. So this will be bute 1,4-dioic acid. Now, how do I name it? This is the location. This is the location. This is the counting, and this is the naming. So LCN. Okay. So that was the second thing I asked you to remember. Okay. So I'm gonna do some practice with you. So go on. These are from, I've picked them up from the past papers. Okay, so let's try to do them. So this one is from 2021. It says that name this compound. So this is from 2021, 1 mark question. Let's see. So I have 3 in the parent chain. So this one is prop. Then this one has carbon parent जो है हमारा, it has a double bond. So it will be first carbon here, second carbon here, third carbon here. That is the main point where students make mistakes. So prop 1-ene, that's what this compound is, and then you have 3 chloro. So that is how you name this one. Okay. Then you had this compound. This is the structural formula given, and you had to name it. So again, you have 4 carbons in the main chain. 1, 2, 3, 4. I personally prefer कि हम always try to draw it if you can, especially if you are looking for maybe some double bonds. Although this one does not have double bonds, but sometimes they have double bonds in there. So for example, if I had CH, then this will be a double bond. So try to put double bonds there if you can. You don't have to draw the displayed formula if you don't want. So this one is simple again, 2 bromo, because the second carbon has bromo and this butane. So this is a pretty straightforward one. This last example from your past papers is a skeletal formula, and they want us to name this one. Okay, so again, let's try it. First of all, look at the main chain. So main chain, I can pick like this is my main chain, or I can go like this is my main chain. Again, it's up to you which one you pick at the main chain, doesn't really matter. Okay, so this, I picked this as a main chain. So there's 4 carbons in there with 1 double bond. So but 2-ene. And then I have branch. So let's say this is my first carbon, second, third, and fourth. Sorry, not fourth, with the omega, fourth will be here. So this one is gonna be 2, 3, locate, dimethyl or methyl. 2, 3 dimethyl but2-ene. So that is how you name them. There's some difficult questions for these that I can send to you as a challenge. These are not from past papers. This is from a worksheet from MIT. So in case you are feeling ambitious, so you can work on it. So I've sent it for in the rapid revision. So nomenclature. Okay, again, you don't have to, but if you feel ambitious, you can. All right. There is a very interesting tool to figure out whether you have done it right or wrong. तो आप उससे भी इसको देख सकते हो. All right, so that part is done. Let's move on to isomers. Okay. Now isomers are, of course, making isomers is important, and identifying isomers, making isomers, and naming isomers. All of that is very, very important. So we'll quickly go over the basic idea of how many kinds of isomers we have. We have 5 kinds. There's 2 main categories. One is structural for isomers, and the other one is stereoisomers. So the structural isomers are of 3 main categories. What can you switch with an isomer so that it, like, what can you switch with a molecule so that it becomes an isomer? So you can change the chain that it has. You can make the parent thing smaller or longer. You can change the position where it has the functional group. So functional group है तो functional group की position change होगी, or you can like move the double bond somewhere. And then you have the functional group itself. You can change the functional group, like alcohol say ether bana lo. It's up to you. In stereoisomers, you have 2 options. You can make geometric isomer, which is called cis trans, or you can have optical isomers. Okay, so that is what you can do. So chain, position, functional group, they're all the things that you can change with the isomer to, with the molecule, to get a different one. So for example, I have this compound. So how many different isomers I can make out of this? So let's start by changing the number of carbons in the chain. Right now I have 4 in the chain. Let me put it 3 in the chain. So if I put 3 in the chain, fourth one goes somewhere else. So I'm only changing the chain. I'm not changing anything else. So fourth one has to go here or here. So there's two options. I can put it here or I can put it here. Isomers. Okay. I can even make 2 keychain. So I can make it like this. And now the other 2 will have to go here. Notice that if I put it here, then that is not an isomer. That's technically this thing again, because it doesn't matter, because the parent will still have 3 carbons in that case. So I have made 3 chain isomers of this thing. So that's one option. The other option is I can switch this one. So I can move this OH from the first carbon to somewhere else. So for example, in this one, I have how many options of positional isomers? This can go 1, 2, 3. Now here's the thing. Is it 3? No. Why? Because when it comes here, then this simply becomes 2. Always go for smaller numbers. The first rule. So this one has 2 positional isomers, 1 or 2. Okay. This one has, let's see how many positional isomers. If it comes here, here or here, it's the same. So look for identical positions. So this is 1 positional isomer and then the one in the middle. So there's 2 positional isomers here. So 2 positional isomers here, 2 here. Let's try this one. How many positional isomers here? If it's here, then it's on the second carbon, right? Because in the second carbon in the chain. So this is technically an isomer of this one, okay? That there is 4 in the chain. So this is technically the same thing. I'll just skip this one then. Yeah. And then you have this one. So this has only 1 here, or it can go here. But if it goes here, then it is the same as this one. Okay. And again, this one does not have 2 in the main chain. This one has 3 in the main chain. So ये भी हमारा उसी का isomer होगा. So do you notice कि if you just focus on the chain and you're like, okay, ये different हो रहा है या नहीं हो रहा, you will see that you are making mistakes. Okay. Yeah. So technically we're down to what? 4 and 4 isomers. Okay. For position and chain. Now let's look at function group. Can I make function group isomers? Yes. For that, analyze the function group itself. OH. So O and H can be split up. So I can make it O separately and then carbon in the middle and then H. And that will create some isomers. So I can have, so how do I do that? For that, I have 4 carbons. So I can be like, okay, out of 4, I can put 2 carbons on one side, O in the middle, 2 on the other side. So this is a, what I like to call it is a 2-2 breakup. Similarly, I can have a 1-3 breakup or I can have a 2-2 breakup. There's the only option that I have. I don't have any other option of breaking the functional group. So if I do a 2-2 breakup, this is what I get. If I get a 1-3 breakup, then this is what I will get. Okay, so those are the only 2 options for basically breaking them up and all that. This one does not have stereoisomers because it doesn't have 4 different groups, but there are some that can be attached to 4 different groups. So the best way to do this is to just quickly go to the questions and try to solve them. Cis-trans isomers इसमें existing करते हैं because you don't have double bonds. Okay, so considering all of that, let's look at some questions. So this question is that find, okay, this one's easy. Okay, these are pretty basic questions. Okay, so this one is about naming them. Okay, so how do we name them? First, we identify the main chain. So this is 1, 2, 3, 4, 5. So that's the main chain. So it is pent. Main chain has single bond, so pentane. and the main functional group is also just single bonds of pentane. But then it also has a branch. So if this is the main chain, then this is the branch. So it will be 1 methyl pentane. There you go. Okay. So there's that. There's also other ones, but we have done more difficult ones. So it's उनको करने का ऐसा कोई फर्क नहीं पड़ता. Okay, let's try this one. Okay, so we have to name this compound. Let's try it. So again, you have one carbon with 3 methyls attached to it. Does that make it 1 methyl? Trimethyl? No, because the long chain will be 3 carbons. So let's first draw it out. That will help. So OH here, and there you go. Okay, so you can see that you have 3 carbon in the main chain, 1 branch here, and the other alcohol there. So this is going to be prop 2 ol. Propane 2 ol भी आप बोल सकते हो उसको, which is a better option, but prop 2 ol भी कह सकते हो. And then you have 2 methyl, because the second carbon has, this one has this as well as this. This is a tertiary alcohol because it has carbon attached to alcohol attached to 3 other carbons. Alright, let's try this one. So this one is a cyclic compound. So this is hexane. So cyclohexane, of course. And then it also has methyl here as well as here. So it is 1,2-dimethyl cyclohexane, because वो मेरे पास इस तरह से आ गया. Alright, so we have done more difficult ones here. Okay, now let's try to okay, so now we are gonna do some past paper questions for this. So let me get a worksheet. Just give me a minute and then we can start. Alright, so this is a worksheet from past paper questions, and this one says that, let's look at it. This compound exists as a pair of stereoisomers. Name the type of stereoisomer shown. So there's 2 types. There's the geometric one and there is the optical. Now, geometric one happens if you have double bonds and if you have 2 same groups attached to them. But this one has no double bonds. So this one is going to be optical. Okay. And optical happens if you have 4 different groups attached to the same carbon, which you can see this carbon has hydrogen, OH, CN, and CH3, 4 different groups attached to it. Okay. Draw a 3D diagram of this pair of stereoisomers. So first step, identify the carbon that is chiral. So in this case, this is my chiral carbon, the one in the second one. Okay, so now I put that in the middle. Now, how do I make stereoisomers? Really simple, follow this diagram. So 1, 2, dotted line, wedge. Okay, now put a mirror in the middle, and now you have, just reflect that one. So dotted line, this, and the wedge. Okay, so you have the basic structure. Now just arrange them. Okay, so this is H, OH, CN, CH3, and now when it reflects over there, so this will become CH3, OH, CN. Notice that I write CN, not NC. Okay, remember that it's the carbon that's attached, not nitrogen, and then hydrogen. So we have created the function group, the chiral center. Okay, so 3D diagram. Give the structure of the organic product of the reaction with dilute sulfuric acid. Acha, ye reaction I'm going to skip on that for now because today we're just focusing on isomers and nomenclature. So I'm going to skip the reaction questions. Unko hum dekh lenge. Okay, what is this compound? Prenol. Okay, prenol is naturally occurring organic compound. Many fruits. It contains both an alkene, which is here, and an alcohol function, which is here. Okay. Prenol can be formed by the reaction of G with NaOH. Okay, complete the diagram to show the mechanism of reaction. Again, mechanism हम कल देखेंगे. आज के लिए हम इस पे focus करते हैं. Prenol reacts with steam to form a mixture of 3 isomers J, K, and L of molecular formula this. तो basically उसने किया क्या है? This thing has now gotten 2 oxygen. ठीक है? उसने क्या किया? Steam के साथ react किया है. 2 oxygen अब हो गए हैं उसके पास. ठीक है? अब देखते हैं कि ये किस तरह से रिएक्ट किया होगा. What is the question? K and L are stereoisomers with molecular formula this. Stereoisomers, they could have double bond or they could have simply a chiral center in there. Does this have a chiral center? I mean, prenol does. Prenol doesn't, G does. G में भी बल्कि नहीं है, तो इसमें भी नहीं है, इसमें भी नहीं है, तो अगले वाले में बनेगा. Unlikely. Unlikely. With steam, it's just gonna break the double bond, add the hydrogen OH there. अच्छा जी. K and L both react with heated excess acid for potassium dichromate to form M. तो ये हमें क्या बता रहा है? ये हमें बता रहा है कि it can oxidize. Okay, that's the key thing. And what can oxidize? We can oxidize alcohols. Primary alcohols can be oxidized, secondary alcohols can be oxidized, but tertiary alcohols cannot be oxidized. So if you're getting steam to react with it, we get alcohols, and those alcohols can further be oxidized. If it is primary alcohol, it will oxidize. Secondary alcohol, it will oxidize. Tertiary alcohol, no. So that's the thing. Primary alcohol यहाँ से कहाँ से बनेगा इसका? Primary alcohol तो ये है already. Secondary alcohol कहाँ से बनेगा? This carbon, if it gets an OH, then it can make a secondary alcohol. If this carbon gets an OH, then that will be a tertiary alcohol, because 1, 2, 3, 3 हमारे पास हो जाएंगे. वो ऑक्सीडाइज नहीं होगा, ये ऑक्सीडाइज होगा और ये वाला ऑक्सीडाइज होगा. It will lead on to become a ketone. अच्छा जी, आगे क्या पूछ रहा है वो? Give the structure formula of K and L. K and L react when heated with excess this to form M. अच्छा, तो K and L जो हैं वो दोनों ऑक्सीडाइज होते हैं. कहाँ से बने हैं वो? K and L can be formed from this. So let's try it. So K and L both are made by breaking the double bond in the middle. So let's try it out. One option is I can give the CH3 here, CH3 here, H, CH2OH. So everything else is exactly the way it was. और मैंने इस bond में H and OH add करना है. So I can add OH here, and that means I get H there. I'll make a copy of this. Second option is that I can get OH here and H here. Okay, so why are they saying that they have J, K and L? Why? How does it have three different isomers? हमारे पास तो दो ही बन रहे हैं. For that you have to look at how they're arranged. If you notice, this is a tertiary alcohol, but this one is a secondary alcohol, but there is something else special to that one. This carbon is attached to this group, OH group, hydrogen, and this whole thing. This carbon is a chiral carbon, and when it is a chiral carbon, that means it will obviously show two isomers, and that is why you have K and L. Okay, so give the structure formula of K and L. Structure formula is still that same one, so it's gonna be CH3, CH, then branch CH3. Notice that I'm starting from here. So this is CH3, this carbon has H, and then this is in the branch, and then I have CHOH. I'm moving from left to right. हर carbon को आप one by one लिखते जाते हो, and then I have CH2OH. So you can clearly see that this one is a chiral center. Alright, name the type of this one shows. So these are optical. That's the type of chiral center that this one shows. Okay, next question. Some reactions are shown based on methyl propan 2-ol. Okay, so हमें ये मिल गया. 1-bromobutane is a structural isomer of the product. So उसने क्या किया है? उसने OH की जगह पे Br लगा दिया. Everything else remains the same. So ये क्या है? ये substitution reaction है. किसकी substitution है? ये हमारे पास OH क्या चीज़ है? It's a nucleophile. Okay, so OH has been substituted with Br. So it's a nucleophilic substitution जिसके through हमें वो चीज़ मिल रही है. But define the term structural isomers. So what are structural isomers? They have same molecular formula, but they have different structure. Right? It's really simple. Structural isomers differ by the structure. So they have same molecular formula but different structure. आप कह सकते हो कि वो different structure उनका जो है वो कहाँ से आता है? Let's see. Name the three different type of structural. So you have chain, you have function group, and you have the positional isomer. So those three options that we had. The product of reaction 3, methyl propene, does not show stereoisomerism. Give two reasons why methyl propene does not show stereoisomerism. Now, this is where many students know that stereoisomerism ये नहीं करेगा, but they don't know how to write it down. So, what kind of compounds do stereoisomerism? They have two superimposable isomers, okay? And these are mirror images that are superimposable, okay? If that is the case, then you have you don't show, the compound does not show stereoisomerism, optical isomerism. So there is the mirror images are superimposable. So that is basically what you have to say. And secondly, the thing is it doesn't have a chiral center. Does it? Yeah, it might, but the अभी बना लेते हैं इसको और हमें मिल जाएगा chiral center. Methyl propene. So this will be in the branch, I guess. Yep. So while you can have maybe think कि अच्छा ये देखें यहाँ पे कोई chiral center नहीं है, यहाँ पे नहीं है, यहाँ पे नहीं है, यहाँ पे नहीं है. So obviously there is no chiral center here. But you can also say that it has a carbon-carbon double bond or carbons attached to same different groups. Why? Because chiral center ना होने से तो उसने ये नहीं किया ना. Geometric isomers भी तो बना सकता था. So why doesn't it make geometric isomers? Because this carbon is attached to same group. And this carbon is also attached to the same group. So carbons in double bond or carbons in carbon-carbon double bond are attached to same two copies of same functional group. Okay, so that is, you can name it as well. You can be like they're attached to two hydrogen, or you can say they're attached to two methyl groups, and that is why it doesn't. So geometric. So this question is a 2-mark question. 1 mark for mentioning the mirror images, and 2nd mark for mentioning the why it doesn't make geometric isomers. So 1 mark हमने बता दिया optical का और 1 mark बता दिया geometric. So that's basically the kind of question that they ask. You will notice कि isomers के ऊपर MCQs बहुत ज़्यादा आते हैं, and we will do some MCQs as well. But theory questions में इसके इतने ज़्यादा question नहीं आते. Alright, now here's the thing. These questions, the ones that we've seen so far, they are just a basic idea that I want to give to you कि questions किस तरह से होते हैं. Mainly, we will be able to handle organic question once we review the kind of reactions that we have. You notice that we have skipped many questions like this reacts with this to make this, and what's happening there, what's the mechanism. Once we understand that, then we will be better able to use all of it. So आज का जो topic है, इसका मकसद सिर्फ इतना सा है that you know the terms you're required to know. You're able to name them, you're able to identify the isomers, you're able to draw the structure. These are the 4 main requirements of today. अगर आप ये 4 चीज़ें कर रहे हो, then in the next class we will start with the next ones, और जैसे जैसे हम करते जाएंगे वैसे वैसे हमें उसके reactions वगैरह पता लगते जाएंगे. And after that we'll be better able to handle the past paper questions. Any other question that you have for me, please feel free to share, and do invite your friends to the channel, like and subscribe and share this. And yeah, I'll see you tomorrow inshallah. Bye.